Hello everyone. In this video I want to talk about two advanced techniques in SolidWorks. One is chamfer for objects like this oblique cylinder, for which if you want to apply the chamfer here on this top edge, it might not be possible for specific angles. Okay, so that's one. The other one is I want to show you composite curves and how to use it to create a tension spring like this. So let's go to the first one. So here, as I said, this is an oblique cylinder. And if you want to apply the chamfer command here, we'll see that for specific angles, this is not possible. So if I choose this, you see for 60 degrees, I'm doing fine, right? I can do it, although it's not really what you think, right? So here I go for 0.3 inches distance and 60 degrees. You'll see that it is gonna go something like this, which is not the same distance all over, okay? And if I change that angle now, if I go back here and try to change that angle to 45 degrees, look, now if you say okay, it says, hey, due to geometry condition, I cannot do it. So if I want to do a 45 degree chamfer with 0.3 inch distance, I cannot do that. If I increase the angle to 60 and up, I might be able to do it, although that's not what you typically expect from a chamfer, because it's not uniform all around the edge. So if you want to perform this task, the way to go about it is to basically break this into two parts. Small part on the top, which you want to chamfer, and the bottom part using this command called the split line. And this split line is a very powerful command which can break down an object, either solid or surface, using a sketch into two parts. So here I go to my front plane and I draw a line that would be the boundary of the chamfer, right? So I draw a horizontal line like this, and that 0.3 inch distance that I wanted, I provided here, that offset, and make sure the sketch passes through the entire object, so really like split it in half. So the end of it should not be here in the middle of the object. It should extend beyond the object's boundary. So you do it like that, and now you come here and say split line, and the method use projection, and it says which surface you use. This surface, you can do projection of that on both sides or in a single direction, right? But here, since it's chamfer all around, so we don't want a single direction, we want it in all directions. So we go okay, and now if you can see, this surface is broken down into two parts, okay? This top part and the bottom part, and you can process the top part individually from the bottom part. So now, in order to give that chamfer, you go to the draft angle command and use the manual method and use with parting line, because this curve is your parting line. So it says which is the direction of the pull, and you choose the surface, so it's normal to that. The parting line is going to be this curve, and then you provide the 45 degree draft angle that you wanted and okay that, and there we go. Look here, 45 degree with respect to the surface, and clearly in uniform 0.3 in all directions. Okay, so you can get that chamfer. So you see I use the technique with the split line, okay, for a chamfer that was not possible. The second method that I want to talk about is called composite curve, which again is under here, right? You can see that composite curve. So here you can combine different curves together to make a combined curve, and then you can use that for any purpose, like in this case a sweep. So if you look at this sweep, if I deactivate this sweep for a moment, the sketch for this comes from a helix and two sets of 3D sketches. One is this, the other one is this one. Okay, so I made the helix, which is 6.5 turns, and I use this half turn to make sure that the two ends are in the opposite direction. So the hooks that I create on the top and the bottom are in the opposite direction. And the start angle is not as critical, and then some pitch here. Okay, so that's my helix, and then as I showed you, I need a 3D curve here on the top, and I need some kind of like mirror version of that at the bottom. And you see here these hooks are in the opposite direction with respect to each other, which is a typical thing in tension hooks and tension springs. And then once I have these, and you see each one of them is a collection of three separate curves, right? So if I go back here and show you, so here first I created this curve which is along the XZ plane. It's a 3-point arc from a 3D sketch. It's a 3-point arc, and then followed by another XZ 3-point arc, which is smaller this time. And then I connected it to a 3-point arc, which is this time along the XY plane, along the vertical plane. And if you look from the top, I made sure that they end up at the middle. So you see here, this is the top view. They end up around the middle, right? And here I did not provide exact dimensions, but you can provide exact dimensions. This is just something approximate, but I just want you to see how it is done. So again, a 3-point arc on XZ plane, another 3-point arc on XZ plane, which is smaller than previous one, bringing it back almost to the center, and then a vertical 3-point arc on XY plane here. And all of these arcs are tangent to the previous one. So this one is tangent to the helix, this one is tangent to the previous one, this last one is tangent to this smaller XZ arc. And then I do the exact same thing at at the bottom. And now let me show you that. Let me get rid of this sweep and get rid of this composite curve. So I have these 3 sketches, okay? This one I don't need. Let me get rid of that. So it's this one, and this one. I have 3 sketches. And if I want to do the sweep command, okay, the sweep can be done only along one of them because they are not attached to each other. They are not a single curve. They are 3 separate curves or 3 separate sketches. So here I need to go and say I want to make a composite curve, and it says using what, and I say using this one, and this one. So I combine them into one single curve. Now this composite curve can be used for a sweep command. So I can go and say I want a circular profile, and then I increase the diameter of the spool, and there we go. Here I got my let me hide the curve. I got my tension spring, as you can see, and I applied some material. So this is a common tension spring. Now again, in tension springs, these coils are typically attached to each other, so the thickness is a little bit more than 0.4, okay? So these are almost attached to each other. And again, here I did not go with exact dimension because that's not my goal. I just wanted to show you composite curve and what it does. But I showed you how to use that to make a tension spring with the hooks. So hopefully this video was useful to you, and I'll see you in the next lecture. Thank you.